Thank you. Hello, I'm May Sauda. I'm from Iraq. I had the master degree from University of Baghdad, and I'm working in Iraq University. My research is the finite element simulation of a cracked dentin. Here this outlines introduction, materials and methods, numerical model, and the procedure, boundary condition, loading model, results and discussions, crack path, stress, intensity factor, fatigue life, and conclusion. In the beginning, all human teeth had cracks. These cracks causing pain due to the pressure. The animal dentin junction improved fracture resistance. And hydrogen is the spread of cracks. The linear elastic fracture mechanics and finite element analysis is used to mimic the stresses distribution and fracture path in oral biomechanics. This research study how the forces, intensities, and dentin properties influence fracture development using cycling load and peak stresses analysis to determine the stress and intensity factors and predicted fatigue life. Here's the materials and methods. This 3D 3D human teeth is a real human teeth was scanned by Helios scanning software. And then in dentist clinic. And then we use this 3D model and import it to SolidWorks to make the 2D section. And this 2D section import to ANSYS to make meshes and boundary conditions and allowances. Boundary conditions and meshes. The distributed normal load is applied to the top of molar tooth and with maximum chewing force of 453 Newton. Use the crack propagation was automated uses the maximum stresses criterion with the crack axis oriented perpendicular to the applied load. The crack direction was brought by maximum tangential stress theory, which directs to the crack toward areas of peak. This tooth is fixed in ANSYS in this way by to like it the real tooth in gum and mouth. Loading model, the beating force of 453 Newton was applied obliquely at a 45-degree angle to long axis of the tooth. This approach simulates the stress state of tooth during occlusion, utilize the stress distribution normal to the oblique surface. This point is the maximum stresses, and in this point will the crack initiate. Loading model, a range of loads was applied to study the compare of extension of crack growth. Three loads was applied to compare and crack extension. And here is the comparing extension. In result and discussion, the crack initiate at the point of maximum stress on the ground and the propagation longitudinally. The stress at the crack tip it is illustrated at both of the initial and final location. The program was executed under two cases of dentin properties, one with the minimum values and other with maximum values. Analysis of these two cases revealed the maximum anisotropic tooth required approximately 100 Newton more force than the minimum anisotropic tooth to reach the crack growth stage, as shown in this figure. And uh, to verify the performance of two fillings, one for filling zero 115 and other for filling IPS impress. And in two cases of the shape of the cavities in the place of filling in the tooth, which are square filler shape and round filler shape, to study the effect of gravity shape to development of the fracture and to compare the performance of two filling. The result of the NCID program is two filling the Filtec and IPS and two cases round and square are shown. The result of the filling IPS showed the emergence of the fracture starting point at the bottom of the upper surface to the tooth and middle. Stress intensity factor. The relationship between stress and the intensity factor and the crack length was plotted with the different loads. As the load increase, the stress intensity factor values also increase as expected. Meanwhile, where the crack length has a moderate effect of the stress intensity factor, ultimately the higher stress intensity factor result in a lower number of fatigue cycles needs to achieve final failure. Fatigue life, a high stress intensity to lower number of fatigue cycle required to reach final failure. The stress capacity decrease as fatigue life increase. Fatigue life measured in cycles refers to number of loading cycles a material can endure before failure. Generally, the curve indicated that as the number of cycles increase, the material's capacity to withstand stresses without failure decreases. A comparison with the literature is shown. My current work is compared with the other research to verify. And conclusion: the analysis showed stress distribution across the tooth with the highest stress contracted at the top and at the base near the middle projection, identified it as the crack origin point. The loading type scientifically influence the crack development with the loading at 45 angle producing a crack cross patterns more aligned to with actual condition that vertical load. The crack length increasing non-linearly with applied force showing at the direct proportional higher force to longer crack and vice versa. Cracking formation and growth are directly dependent on dentin properties. Individual high with higher dentin properties can withstand greater forces without crack development compared to those with lower dentin quality. Stress intensity factor values are influenced by both applied load and crack length. Dentin behaviors similarly to other materials under fatigue loading as capacity to endure stress without failure diminished other time. Thank you for attention.